Okay, now for the collision system. So here is a class diagram of the overall system. We have our test commands and everything, test terrain, self-pair, TRA iterator, and all our collision volumes. So if we want to go ahead and look first at the collision volumes, so over here in the test OBB, we have it abstracted into this bounding box where we handle all of the data between ABB and OBB, and this was very necessary for all of the testing that happens between the different volume types and everything. See here, the ABB doesn't define any of its own variables. That's because the OBB also needs these variables, so it's better to just store them inside of the parent and have the ABB do its special computation, whatever it needs with the min and max corners on its own. And here, obviously compute the data that it needs. Here in the bounding box, we compute all of our data that we need for comparisons between these two. And as I said, here's the B-sphere as well, and here in each of them, we also compute our initial test B-sphere. If we go over here, we just we'll do a simple computation of something a little bit larger, and here we have the attorney, so the user doesn't have to do any of this. Inside of the collision volume, each collision volume holds only one of these, and the reason we know it's only one of them is because you have to call this initialize function in order to do that, and the initial test B-sphere isn't calling this. Okay, so inside of the collidable, here's what the user sets their collider model to each whichever kind that they need. It sets up the commands and the model that they can set from their graphic object, but they don't own any graphic objects personally. The user calls submit collision registration in order to register for collision, and they get their collision volume right here, and they can update their collision data and everything, and the collidable does own several things to help with deletion in constant time and everything here. Terrain delete, collidable group delete, and then our various template functions here for the terrain and setting the collidable group. And this here get collision volume is very useful for when we're using the visualizer, which I'll show in a little bit. And then over here in the collision group, we have our group ABB, our big old box, and the terrain collection, and just a bunch of type defs we're using. And we have constant time erasure, and then the registration stores with the variable. And we update our group ABB here if we have anything inside. And we set the with the attorney, set the corner max and min of our box as well. And the update group ABB only gets called once per frame, per group, that is, because in here we do call process collisions before we actually process the commands and everything. And then this only gets called in the scene once in every update. Now that we're in the collision manager, we have our processes. It doesn't have that much to do besides handle the pass-through functions for everything and setting the group types and everything. The header has more action than anything else, but we assign a bunch of values to start. We clean everything up over here. We set our type IDs for whatever wants them, register for terrain collision, and everything like that. We create one command per thing that registers for it. As we know, this gets called in the scene and everything. And then in my dispatch, I have the terrain callback right here as well, calling to collision terrain on anything that registered for it. Now to go through each of the individual commands, in here, the commands have their data set up and everything. We have our tiered collision testing. We're in the same group, so obviously we know that we can't use the group to test initially, but we get to do our initial test B-sphere before testing the actual collision volumes of them. And then if we go into the test pair, here is where we actually test the collision groups against each other. We test both of their group ABBs with this intersection. We go in, it does the interval test on that, test the B-sphere against the group, and then we test the initial B-spheres and then the intersect between them, and then we do the callback. And this is what we were seeing when I was showing the CAD-CAM earlier, is these two visualizations, showing them based on whatever collision volume they have. And I suppose this would be as good a time as any to show how that works. So here in our visualizer, we pass in a collision volume, and it calls debug view on the volume, which can go into any of the appropriate functions for each of the collision volumes, which will go into the visualizer and then create the command from the object pool associated with it. And that will pass in the command to our visualization loop, visualize all. And this makes sure that we don't have any duplicate things happening over here, and this only gets called once. Over here in the draw step, and this is a top level thing just so the user doesn't have anything to do with when that gets drawn. And I also have the show segment function here, which shows off things for the norms and everything like that. I have a show point one as well. And I can show different visualizations depending on, I create an ABB given certain values and everything. This is useful for any kind of visualization the user would need to do for whatever. Here I could have recycling and everything too. And a couple of graphics objects just so that we can render everything using the same thing and we don't have to waste a bunch of process time creating graphics objects. With that tangent out of the way, let's go inside of the collision test terrain command, since this is a little bit into the terrain, but still with collision. So we make sure that we get our group of cells to iterate through. We make sure that we're not have anything invalid for any wonky thing where somehow the player gets off of the map or a game object does. And then we test intersection between the cell AABB and the collision volume of whatever is testing.